In this lab, like the previous lab, we will observe charge transfer. However, at this time, we will be able to see the quantitative charge, not just observing the phenomenon. Furthermore, at the end of the experiment, we will construct a hypothesis about the transfer of charges and polarization with a neutrally charged object.
For the materials section of this experiment, we have split the materials into two parts. The materials for parts A through D are labeled with letters, and the materials for part E are labeled with numbers. Those that are within both categories have both labels but are separated by a comma. Now, for the materials for parts A through D, we'll start with A. That is the electrometer with the connection wires and the cage, which is what we are exposing objects to read the charge. And then the electrometer itself is what tells us the charge. B is a piece of dangling aluminum foil that is grounded to the table, and the aluminum foil is a neutral conductive object. C is a PVC rod. D is a glass rod. E is a plastic rod. F is a pith ball, which is basically just a tiny piece of aluminum foil dangling from a string, and it's meant to be a neutral, conductive, and isolated sphere. G is a silk cloth. H is a piece of fur. I is a wool cloth. Now for the materials for part E. We have two neutral spheres, which are what we are attempting to charge in the last part, a plastic rod, which is also in the materials for parts A through D, labeled as E, as well as the piece of fur labeled as H from materials for parts A through D.
Whenever you're ready.
It's recording.
Okay.
Moving into the core data for lab number 2, our first objective was to establish a reliable charge reference for the materials used throughout the session. We utilized an electrometer to quantify the polarity of 3 specific rods after being subjected to friction with various cloths. As shown in Table 1, guide of the different rods' charge, our empirical results were consistent across 3 different friction sources. The first rod that we tried out, the acrylic rod, consistently produced a negative charge when rubbed with fur, silk, or wool. Our second rod, the glass rod, resulted in positive charge across all 3 mediums. And lastly, our PVC rod also registered a positive charge in our trials. This data served as our ground truth. By knowing the exact charge of these rods, we could then isolate and identify the behavior of neutral objects, such as the grounded aluminum foil and the isolated pith ball, in the subsequent phases of the experiment. With these baselines established, we can now analyze how these known charges influence the motion and charge transfer in parts A through E.
After our pre-lab, we started our lab. And for part A, we did pick the PVC rod and the fur to continue all of our other experiments. So for the first one, we did charge the rod, and then we checked what would happen when we got close to the aluminum foil, the hanging aluminum foil. For part B, we did the similar thing, but this time we did make contact with the rod to the aluminum foil, took it away, and then returned.
This being attractive.
It is attractive.
And then touch it again.
No, touch it this time. Okay.
Are there any changes with aluminum? Our next step for our lab 3 was part C, and it was using the same fur and PVC rod. We conducted similar experiment of charging the rod, but this time we saw the attraction or what would happen with the pith ball. From there, a part D was once again using the same rod, charging it, and then we touched the pith ball, separated the rod, and then brought it back to see what would happen. And then for our final part, part E, which was extra credit, we used the acrylic rod and then the firm to create the negative charge rod, and then charge the two spheres that we had. We put them together that they were touching, and then we only charged one of the spheres using that rod. That rod was negative, so the sphere would be left positive, and because they were touching, the sphere that was being touched with the rod would remain positive, and then all the electrons would move to the other sphere, creating a negative charge. And then we were successful in charging one sphere positive and then the other negative. I'll move this one out of the way. And then we said it's going to attract.
It is.
You see it?
Yeah.
Yeah. Okay, so it. What is the pitfall? Is this the pitfall? Or is it so if you want, I can do like this. It is attracted. I touch it. I'm gonna take it away. I'm gonna let it. Sorry. I'm gonna start moving, and then I'm gonna bring it back. Ooh, I touched it.
It's okay. We won't tell anybody.
Try to do it like a C, like around here, or C, like that. And try not to touch it.
We can. We can go to the. So it's a little piece.
For how long?
As long as you feel like, I think. That way we get the most charge as possible.
Yeah, if you want, you can stop, check the charge, and then recharge.
For the conclusion in part A, it was the aluminum foil and it was attracted to the charge rod. As we know, charges move closer to the rod while like charges move further away. And since the foil was completely grounded, excess charge flow from the ground and it just make the attraction waves strong. And for part B, it was the aluminum foil and this foil was repelled when it was brought close to the rod again. And then the charge was transferred by conduction, leaving the foil. And since like charges repelled, the foil ended up moving away when it was brought near again. For part C, it was with the experiment with the pitbull, and this was attracted to the charge room. And the polarization still occur on this one. The side closer to the rock became completely oppositely charged and it ended up leading to the attraction of it. And for the last part, it was part D, and this one was the pitball repel when it was brought into the rod again. And the ball moved away from the rock.